Also, so we had a repeated question on our second exam, right? That was the question about, that was the question that was similar to this. Let's see, what was it? It was the sum of the digits, right? Yeah, this one. It was similar to this, except asking for the sum of digits, I asked you to multiply, give me the product of the digits, which is that was the question on exam 2. It was also the same exact question that was on exam 1, and I told you guys it would be that a question would be on exam 2, and then I gave you hints in the practice exam by having problems about digits on the practice exam. So, and I said that basically we would take that question and any difference between the points would be added to your score. I decided to just forgo that, and under your exams you'll see that there's a you'll have exam 1, exam 2, and then make-up question or something from exam 1, and that's going to be out of 0 points, right? That just means that anything is that's your score for that specific question, and you'll see that anything that's just basically whatever you got for that is just going to be tacked onto your total exam score. So it's like an extra 10 possible points. So if you were able to do that question, then that really will have helped your grade. So anyway, okay. Again, this will be open note. So and you can bring for this exam you can bring as much note as you want. So anything that's on paper that you print out, it's fine. You can bring your practice exams. Just basically, if it's on paper, it's good. Okay. That being said, right, there's only a limited amount of time. I still recommend maybe making 2 or 3 sheets and just bringing those in, and then maybe bringing in previous exams for reference. Okay. Never leave it blank. Clarify your answers. Right. Bunch of stuff here. How to use regular expressions in a way I care about will be listed here, as well as reminders of the special about the special codes we care about. Right? How to read a file into a string. Right? How to write it. Okay. So let's go ahead and get this started. Write a script that, given a text file, finds and returns all the superhero words in it, which are words that end with man, woman, boy, or girl, such as Supergirl or Batboy, right? So first off, let's figure out what the regular expression for that is, right? We want to find all the words in this. And we can assume that all words are separated by, okay. So let's go ahead and, sorry, Kini. All right, so let's go ahead and just go at classroom in ITP. Final exam review. .py. Okay. And now let's go ahead and create a new file, which is let's call it ITP in ITP. Let's call it a hero.txt. Superman, Batwoman, and the boy, and Wonder Dog to the rescue. Off to save Batman. Okay, so we will go ahead and try to, this one will be fun. I'm just going to do that as a demo just to test ours. So def find superheroes, or find supers, and let's just go ahead and give the file name as our argument, right? I didn't provide you much for that, but I'm just going to say, because I was really just kind of more I'm just going to put it in its own function so that we can have it easier. So find supers. So we are going to open file name R text, right? And we're just going to say, and then we're going to say supers is equal to an empty list because we're returning a list of all those things. For text in, for line in text. Let's see if find all is enough for us to do this, right? Also, we need to, if we're going to use regular expressions, we're going to import RE. Okay, supers. Let's go ahead and make our super regex is equal to re.compile. Right, so knowing how to open the file, that's a bit of points, but the regular expression is also good. So what we need to know is that we're looking for something that ends with man or woman, right? Was that it? Man or woman? I'm just double checking here. Yep. Man or woman or boy or girl. Okay. So let's go ahead and do this. So we need man or woman or boy or girl. Right, that is the regular expression for that, or that will find man, woman, boy, or girl, but it won't find the whole thing, right? For line in text, super regex dot find all line, right? If we print that out, find supers file name. Nope, got to give it a file name. Hero.txt. Oh, it's all lowercase. All lowercase. Boy, woman, man. But we need the super or the bat part of it, right? So really what we need is some number of words, some number of any number of letters, followed by a man, a woman, a boy, or a girl. Let's see what happens if I run that, though. Man, woman, boy, girl. W plus man. What if I do this? /W plus man, or woman, or boy, or girl. Unbalanced parentheses, because I forgot to delete that parentheses. Goes boy, woman, and Batman. Or boy, Batwoman, and Batman. So if I do it like this, what happens? Capture groups are still Superboy, Batwoman, and Batman. But this should what should I generally care about is this. Boy, Batman, Batwoman. So it doesn't get super, which is interesting. Oh, so why isn't it doing it? It's looking at / plus man or woman or boy or girl. And remember, because of the way English works, man is part of woman over there. So it just simply was reducing to this, right? Because this catches woman as well. So if we want to be explicit without the groups, And that will get that all those. If it's boy, girl, that, and then basically, and then all we have to do is supers plus supers plus equals super regex dot find all. That's just one way to do it, by the way. And then, oh yeah, print it out. Sorry. Return supers, print, find supers. And that will get all of them, right? So basically this will return a list of everything it finds in that line. And then it will do the following. Now, the way find all works with groups, let's go ahead and look that up really quickly, because find all Python regex groups. I know you can connect. Okay. So it returns this. So it will capture. So regex will capture the groups with find all. It'll be a list of tuples if there's more than one group. So so if you use parentheses, you just gotta remember that you're going to be capturing basically a group of stuff. So that's why I had to separate it out like that if I'm not using parentheses, because otherwise it will capture it as a group. I'm not really going to pay too much attention to groups, though, when we go over in the exam, though. So what I care about is more of the diction like this. Right. So let's see. I also sent out a link saying what is the difference between match and search. So just be aware of that, but again, it's not going to matter too much. What we can do over here as well is that we could say, if we wanted to be, we could also, instead of using find all, we could use split and split along the words, and then do find all on and then do a match on each word. That's one way to do it. Again, what I care about more here is the regex than anything else in these kind of questions. It is possible to do it without regex, though. And the way you could do that is for line in text. Some problems will need regex, like the social security number one. Or if that doesn't need it, it's just needlessly more complicated if you got. But we could do line dot split on space. Line is equal to line dot split on space. For word in line dot strip out your commas, right? Strip out your commas. Oh, no, sorry. Word is equal to, so we're going to strip out those commas that are in there as well as any other punctuation. And then we can say, hey, if word -3 to the end equals man, or words -3 is equal to boy, or words -4 is equal to girl, then it's a superhero word, right? So that's one other way to do it. I will not bother finishing out for sake of time. Let me also just be clear about what the problems on the exam are going to be for our regular expressions, right? There's going to be two sets of problems on regular expressions for the final exam, about 20 points on the exam. The first is, again, the one I've already told you about, which is given a file with a bunch of a text file with a bunch of text and a bunch of social security numbers in it. I want you to create a new file with all the social security numbers replaced with redacted. Okay? So I've already told you what 10 points on the exam are going to be, right? And remember, and the regular expression for that isn't hard. It's just a bunch of /Ds, right? It's a bunch of /Ds and dashes. That's all you need to do for that one. And then you got to open the file, right? Read it, and then output every line, except every time you find a regex, you replace it. Well, how do I replace social security numbers then? Well, I tell you on the exam how to do that, right? I tell you right over here. The thing you use to replace, and you create your regular expression, and then whatever you want to replace that regular expression with, you replace it in the target text, and it will replace that what you matched with the target text. Okay? This is something I highly recommend you work out on your own at home and bring it into the exam. I'm being generous here. I'm telling you what the question is going to be. The other regular expression questions, by the way, are going to be much simpler because I'm not going to involve you writing a regular expression. Instead, I will give you a regular expression. I will either give you, there'll be kind of multiple choice, kind of. I'll either, depending on the question, you'll get a regular expression, and you say, and I'll ask you to bubble in the words that it matches, or given a word, tell me regular expressions that would match this word, right? Or bubble in the regular expressions that would match this word. So not writing, just here's given, tell me if they match, right? So that will also be around 10 points or whatever. So those are your questions for regular expressions. You are not limited to using regular expressions on only those questions, though. Those are just the only ones that will involve regular expressions as a necessary solution. Okay? Hopefully that reduces your stress a bit about the regular expressions. What kind of regular expressions? I highly recommend looking at like page 1 and page 2 of the homework that you've already done, or we're currently working on. I'm a big fan of currency. I won't be using US dollars on the exam. I'll use another currency. But, okay. So that should give you some more information. Okay. This page deals with nested lists. So note that nested lists will be on the exam in some form. They're not, but we see that later in the exam, the kind of difficulty you should expect from nested lists. Consider the following list. List of lists, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. What is the length of this? 4. There are 4 items in this list because there are 4 lists in the list. That's what the length asks. Length is very specific. It asks for how long this thing is, and this thing has 4 items in it. Now, each of those things have 3 items in it. But it's asking like a one-dimensional question here. So what is element 2 of this? Element 2, is it 2? No. Is it 7? No, it's not 7. It's 7, 8, 9. So, right, this is index 0 of LL. This is index 1 of LL. This is index 2 of LL. What is the sum of LL2? So, in other words, so the sum operation, right, automatically adds everything together in a list. So we're asking the sum of LL2, which, by the way, is LL0, LL2, 0, plus LL2, 1, plus LL2, 2, and I'm horrified to realize that I don't think I ever went over this, the fact that you can do 2 dimensions like that. I'm horrified to realize that, so I'll have to tell John about that for 1068, but hey, that's just simply saying, hey, the second, here's your row, here's your column. Right? which just simply means that we add 7, 8, and 9 together. Right? It's the sum of LL2, 7, 8, 9. All right. 2520 is the smallest number that can be divided by each of the numbers from 1 to 10 without any remainders. What is the smallest positive number that can evenly be divisible by all numbers from 1 to 20? So this is a practical layer problem, right? Basically, we want to find out what number is so basically, we want to find a number that's evenly divisible by all the numbers from 1 to 20. For a number to be evenly divisible, okay, it needs to, well, to be evenly divisible, that means when we mod it with a number, it's going to end up 0. The remainder is going to be 0, right? 100 is evenly divisible by 10 because 10 cleanly divides it. It's evenly divisible by 5. It's not evenly divisible by 3. We would have a remainder of 1. So let's go ahead and try this. Euler 5, def Euler 5. Okay. So we need to go up and find a number. So let's go with done is equal to false. We don't know what number we're going to go up with to. And we want to basically search up from the smallest number to the large until we're done to find a number that's divisible by all the numbers from 1 to 20. We don't know when we're going to stop, so I'm going to use a while loop. While not done. Like loops like that. I'm going to say our starting point is going to be 2520 because that is the first smallest number that's divisible by all the numbers from 1 to 10, right? So that's a good place to start. Or actually, let's start with num. Say num is equal to 2520. While not done, for I in range. Now, all numbers are evenly divisible by 1, so no need to check that. So from 2 up to, and not including 21, so from 2 to 20. If we want to check basically that this number is not divisible. Not divisible. So, So, if num mod I equal is not equal to 0, in other words, if it's not cleanly divisible by one of the numbers from 2 to 20, then we need to go on to the next number. So we'll say num plus equals 1 and continue. If we get to the end of the loop, we'll say done is equal to true. Actually, continue would be bad. Continuing would continue on with that one. So instead, we would want to break, because that would break us out of the for loop. Let's see. Actually, so the logic here, I'm just trying to make this as simple as possible, but the logic that I've done that to my, so the easiest way, honestly, is we'll say, we'll do good is equal to true. So we'll assume the number is good until proven otherwise. And if it's not divisible by one of our numbers, we'll say good is equal to false, so it's not going to be good. And if good, break, because we're done. Or say, let's say done is equal to true, so no need to break. Else, we guys keep searching. Num plus equals 1. Go on to the next number. So we assume the number we're looking at is good. We check all the numbers from 2 to 20. We ask, is this number divisible by 2? Oh, it is? That's great. 3? Oh, it is? Great. Oh, it's not divisible by 4? Oh, that's bad. We're going to say good is equal to false. and then we'll go through it, and if it's good, we're done, and we'll get out of this loop. Otherwise, we go on to the next number. Return num at the end, so print Euler 5. And so that program will generate and run and run and run. I'm beginning to think that basically, I'm beginning to think that basically that was no good. So print num. So I'm checking so it's checking a bunch of numbers. It is checking them. So if num mod I if num mod I is not equal to 0, right? So it's not divisible by I, so 2 by 3, all the way up to and including 20. If good, done is true, else false. Let's just let it run for a bit to see, because it is doing it in Python, so it could be a bit slower. But object Euler problem 5. Surprised though that it would be taking this long. Evenly divisible with no remainder. Sign in. 96436. Smallest multiple should be, oh, it's quite a large number actually. 5, but it should already be there. Right, it's only in the 100 millions. Right. And we notice that even when it's printing it out, it's already in the 100,000. So let's see. If num mod 1 million equals 0, print num. So this will just print it out. This will print out every time it goes through a million. Okay, so it would take a while. Interesting. I know why it's taking a while though. We already said it. So the reason it's taking so long is that we already say that, hey, oh, it's not divisible by 2? Oh well. Let's check if it's divisible by 3 anyway. So we'll break out of this now and see how much quicker this goes. 1, 2, so that's considerably quicker. But no wonder it took so long. And then let's see. We know if it's not divisible by 2. We know that also we can check. Let's see. We only need to check even numbers as well. So we could increase it by 2. So 2. And this is just tweaking. The program already works. See, it's going much faster now. So that will work. Will just take a while. Not really sure how I got it working so fast in the first place. Let's see. Code Euler 5.py. Oh. Huh. Yeah, I really went out all at that, so. That was, Oh, and it's still running in the background over there, so that's possibly slowing it down too. Okay. Anyway, we've got an answer for that one. That one will work eventually. Let's see. Next problem. Sum of digits. So this should be a familiar problem for everybody. Right? Possibly a hint that this digit-based problem will still be on the exam. So, sum of digits, given a number, right? First off, you can't go 4-digit in num. That just doesn't work, right? Because you can't go through like, or digit in range num. That won't work either. What we need to do for that one is that we've got a couple things. We can say num is equal to string num, right? And then for 4-digit in num total is equal to 0, total plus equals digit int and then that's it, return total. And that's if you're using strings. Another way to do it, again, is to use our method. While num is greater than 0, or while num not equal to 0, total is equal to total plus equals num mod 10, num is equal to num divide 10. So just simply add this last digit, throw out the last digit. Add the last digit, throw out the last digit. And keep doing that until it hits 0. It'll eventually hit 0. Okay. Next, write a function that returns if the string can be spelled the same front to backwards. Now, when I originally wrote this problem, I wrote it for a practice final for my Java final. Now, let me tell you, that required slightly more finesse than it does in Python. So I'm going to show you the one-line Python solution very quickly, and then I'm going to show you the other ways to solve it. Right? This has a lot of different ways you can solve this one. But the simplest way to solve it is return word equal word -1, or slice -1, which says return whether or not the word is equal to the thing equal to the word reversed, right? You can also split that up into multiple lines, but remember, if you want to reverse a sequence, be it a list or a string, you just simply say, put in slice notation from the beginning to the end, but in reverse, please. And that will work. What about, now, palindromes are actually pretty fun. You know, by the way, those are words like radar or sets of words like taco cat or a phrase if you remove the punctuation, like a man, a plan, a canal, Panama. So they're fun, and people get very excited when they come up with a new one. So anyway, it's not too bad. We can basically build it in reversed if we need to. Reversed word is equal to an empty string. And now there's a bunch of ways to do this. For letter in word, okay, return reversed word. in the end, equal to word. So simply check if they're equal to each other. This will resolve to true or false. So that's a perfectly valid way. So what we could say, since we're going from the front to the back, we don't want to do plus equals. We don't want to do this. Reversed word plus equals letter, right? That will tack on the first letter, then the second letter, then the third letter to the end, right? That's no good. But instead, if we switch, remember, this is equal to this. Reversed word is equal to reversed word plus letter, right? This will take what we already have and add letter onto the end. But it's actually a simple change is all we need to do to make this valid and reverse it. If we instead do letter plus reverse word, we'll take the current letter and stick it in front of what we already have. So for instance, with our word, with wolf, W-O-L-F, right? Here's our current thing is an empty string. So if we add that, so what we'll do is we'll go to W first. We'll say put the W before the empty string, which just becomes W. Then we'll go to the O and we'll say put the O before the W, which becomes OW. Then we put the L before OW. Then we put the F before low, and it becomes flow. Now, those words don't work together, but hey, So that would return false, but hey, that works out. Another way to do it is to just simply iterate through it in reverse. So for word in, so you could do the reversed here. Right, you could do it like this, and then just do your standard way of doing it. Or you can go reverse through the indices, which might be a bit more comfortable for some people. So for I in range len of word, from length of, let's see. So actually, we wouldn't want to start from 0. We want to start from length of word minus 1 to negative 1 and go down by the ones, right? Which is honestly looks terrible. So yeah. But that's another way to do that. All right. Write a function called makeUsername that generates a username for a given name and a suffix, as demonstrated by the name below. So you can assume the format of the name is either first name, last name, or first name, middle name, last name. That's a terrible assumption to make, and I'm going to click this link because you need to learn about this. Because we believe many false things about names. So, for instance, my wife's name is Annie Ray. That's not one word, by the way. That's Annie hyphen R-A-E. And you would not believe how many computer systems this upsets. Okay? But that's perfectly valid until we decide to add computers into the mix. And it's even worse if you're a woman and you're going to eventually get married and you're going to go with the current custom of, adopting the name of the person you marry, which, you don't have to do that. You can hyphenate that and make it even more complicated for the computers. And I'm all for chaos. But, of course, that breaks one of the assumptions, that the name doesn't change. People change their names all the time. So here's all the assumptions that are wrong about names. People have exactly one canonical full name. People have exactly one full name which they go by. People have at this point in time exactly one full name. People have at this point one full name they go by. People have exactly n names for any value of n. Names do not change, but they change only at certain events. They're written in ASCII. They're written in a single character set. They're written in mapped Unicode points. Their names are case sensitive. They're case insensitive. People's names do not contain numbers. Names are almost globally used. My system will never have to deal with names from China or Japan or Korea, or Ireland, United Kingdom, United States, Spain, Mexico, Brazil, Peru, Russia, or the Klingon Empire, all of which have weird naming schemes that are used. The Klingon Empire thing was a joke, right? Confounded cultural relativism. People in my society, at least, agree on one commonly accepted standard for names. So, one thing to know, like for instance, when you're dealing with Asian countries, right? In Japan, the family name comes before the personal name, which leads to all sorts of nastiness if you're trying to translate names correctly. Right? People have last names, period. Sorry. Okay, people names are assigned at birth. Okay, maybe not at birth, but pretty close to birth. All right. So within a year or so of birth, right? 5 years. You're kidding me, right? Some societies don't name their kids until after a certain point. Part of it is also, or they don't reveal the name outsider because of superstitious beliefs. I'm sure there was some Jewish belief out there that was about there's some Jewish beliefs about names. I don't know if there was anything that was with that, but I know there was some society that basically you don't reveal the name of the child because you don't want the evil spirits to basically get drawn attention to the child. So we use a fake name instead for the child for the first year of life. Yeah, names are complicated. Don't make any assumptions about names. Just assume that's going to be a string. That's still probably a bad assumption. Okay, so def username, make name. Now here we can assume that the format of the name is going to be first name, last name, or first name, middle name, last name. And what we do is that we're going to take the first letters, and if we look at our examples, we go, okay, so it's going to end with this number. And it's going to take the first letter of the name, and first letter of the first name, and then the first letter of basically each part of the name and stick them together. So if I provide you with first name, last name, it's going to be first letter of those two things. If I provide you with first name, middle name, last name, you're going to get this. So, all right, that's not too bad. Okay. So basically what we need to do is just create the initials and add the number on top of it. That's really all that is. Okay. So we'll say our initials. So we can actually just kind of already come up with part of our answer over here. Say the initials are blank, and at the end we're going to return initials plus str turning n into a string. If you forget to do that on an exam, I'm probably going to forget about it. It's probably not going to count against you, right? Because it's valid in Java. Initials. So initials. So what we need to do is take the name, and we need to split it. Name.split into, and we're going to split by a space, because it's either going to be first name, second name, third name, right? Okay. So, and then for part in name, right? So we split it into first name. This is going to take it from basically being one string into a list of 3 strings or 2 strings, right? Don't really care how big it is because each part is addressed in the same way. What we do is we get the first letter of that part, and we do that by saying 0. I have some people who are still doing this. That's technically correct, but it's also 2 more characters that then you need to write. This will get you 0, the first letter. And then first letter is equal to first letter dot lower. We could also just put the dot lower over here, but remember we wanted it in lowercase. And then initials is equal to first letter, or not equal, but plus equals the first letter. And that should do that. It's not a particularly tough thing. A lot of the questions end up being really simple if you can come up with a way to do it. All right. Note that this one is much harder than what would appear on the exam. In fact, this is a question I give him 2168 and still a mess. Although they don't have dictionaries to solve this problem, which makes it much tougher. Given two strings, write a method that returns if they are permutations of each other. Two strings are permutations if they have the same numbers of each characters. So Wolf and Flo, they're permutations of each other, right? Use a pair of dictionaries to do this. So I need to qualify here why pairs of dictionaries are required. You need to, A, B, the permutations of this string are A, B, A, B, A, B, A, right? Those are the possible permutations of the string, right? There's no other way to arrange those. But B, B is not a permutation of those three, right? It's a different number of B's and A's. They have the same letters, but different counts of the same letters. So notice I give you word 1 and word 2, count 1 and count 2, and then I give you return if those two things are equal. So basically, if we have the same count for each of them, they're permutations. Same, but word 2. Not print. Return. Count 1 equals count 2. So what we do is that we count each letter. So for letter in word 1, if letter in count, if it's, I always like to do it not in first. So if the letter is not in count 1, if we haven't seen this letter before, then how many times have we seen it? We've seen it once now. So count 1 of letter is equal to 1. Else, well, now we've seen it one more time than we've already seen it before. So count 1 letter is equal to count 1 letter plus 1. And then over here on exam, if you get something like this, it's more than fine to just simply write same, but for word 2 and count 2, because you don't have the copy paste function on with a pencil, right? Because that's exactly what I'm going to do here. Also, I'll fix the spelling of return. It's not retunra. Insert mode 2, 2, 2, 2, 2. And that's all you need to do. Count the number of letters. Count the number of letters each time it occurs in word 1. Count the number of times each letter occurs in word 2. And return count 1 is equal to count 2. Another thing we could do, just also off the top, is that we could check if their lengths are equal, but that's fine. Right now, the counts will be different if the lengths aren't equal. Okay. Below average, given a list of numbers, return a new list of all the numbers from that list that are less than the average. So for this one, we have to calculate the average of the list. And then, so we either have to iterate through it twice, or we have to, we have to be clever and know our functions. So Let's go ahead and iterate through this twice to compute the average, right? Def below average. Let's first compute the average, which is just simply by going this. Average is equal to 0 for num in, what did I call the variable? Numbers. For n in numbers, average plus equals n. Average is equal to that total that we did divided by how many numbers there are. So length numbers. But if you remember from earlier this exam, what we could do is just simply say, we can cut that all out and say average is equal to the sum of the numbers divided by the length of the numbers. And in one line, we've just computed the average. Sum is a key word in Python. Okay, next we have so next we have to just compute which ones are the ones below average. So let's see, below is equal to for n in numbers, and now we just have to say, hey, if n is less than the average, then this number is below average, so we add it to the list. Below dot append n. Otherwise, we just keep going on. And then we return below. Now, before I go on, I just want to mention, for those of you who got very high scores on exam 2 or end up with a very high score at the end of the class, I will be looking for more TAs for next semester. So, you know, and I generally like to recruit TAs who have been in this class before, so long as your overall GPA is good. I think they've paid decently. I can't remember if it's $10 or $15 an hour, but it's anywhere. It's initially 8 hours a week of work, but, you know, or you can charge up to 8 hours a week of work, up to 10 depending on how many sections you TA. But anyway, I vastly prefer taking undergraduate students as TAs versus graduate students. So if you're interested, send me an email so that I can get that arranged for next semester. You just have to, you know, I prefer people who end up getting an A in this class. So, sum of tens. I just want to mention that before I completely forgot. Okay, sum of tens. Given a list that contains many integers, return the sum of all the integers that are multiples of 10. So this is a list of lists. So return the sum of all integers that are multiples of 10. So right, the only number that was multiple of 10 here was 10, so we output 10. 10 plus 20 plus 20 is equal to 50. 10, 20, 10, 20, 30 is 90. So we skip numbers that are not multiples of 10. Now it's a list of lists, so we're given numbers. So def sum of tens. So it's a list of lists, so we have to iterate, so this has to be nested. So for list o nums, list of nums in, so for each list of numbers in numbers. Otherwise, it's just simply adding stuff up, and we've done that before. So for every list of numbers in numbers, for number in list or rather, let's call this for inner list in numbers, for item in inner list, right? If num mod 10 equals 0, total plus equals 10, not 10, num. So we go through each of these lists in turn, and in each list we check each number out. And if that number is divisible by, oh, we call it item. If that number is divisible by 10, we add it to the total. And then at the very end, we return total, right? We don't return it anywhere earlier in the for loop. Okay, some 10s. And then finally, a text file problem. Given the name of the text file, return the sum of all the numbers in the text file. Separate by commas. So, for example, a file might look like this. So we've got a comma-separated file with numbers. So given the name of the text file, return the sum of all the numbers. So another summation problem. Really not that bad. Def sum of file is equal to file name. So given the file name. So first we got to do is say text is equal to open. Right? This is very similar. Open. File name. R. And then let's see. We need a total outside of the for loop. Total is equal to 0. For line in file, we know everything is separated by for line in text. We know everything is separated by comma, so line is equal to line dot split across the commas. Okay. And next, what do? We just sum up all the numbers. So, for item in line, total is equal to total plus int item. And that's it. All right, so this is what I have currently. I think that's the last problem. I'm going to quickly look through what I have currently for the final and see if there's any other question, anything I wanted to warn you about, okay? So let me turn off the recording because otherwise it would record me